Hiya, welcome to video number 120. This video is compound measures, density, mass, volume, pressure, force, area. Alright, so follows on from speed, distance, time quite nicely, but it's a level up. Keywords are compound, again explained in the last video when two things are stuck together. DMV stands for density, mass and volume. Those three things are connected. And pressure, force and area, those three things are connected. Alright, they're separate from each other, but they're connected as the threes that they are in. So there's a lovely formula triangle you can remember to help you with these sorts of questions. This is the density, mass, volume triangle. Okay, I've explained what those D and M and V stand for. Again, same as the speed, distance, time, you just cover over the thing that you want and it tells you the calculation that you need to do. If you haven't yet watched the speed, distance, time one, it might be a good idea to, if you're not sure what I'm talking about already. Now, P stands for pressure, F stands for force, and A stands for area. And that formula triangle will be provided to you in the question. Not necessarily in the form of the formula triangle, but that the formula that you will need will be within the question. So you don't have to remember that one for some reason. I don't know why. I don't know who makes this stuff up, but there you go. Right, number one, A asks us to calculate the density when the mass is 2 grams and the volume is 4 centimeters cubed. Okay, don't get thrown off by these units. Don't worry about them. They're just the units of the answer. Okay, so the density is going to be a combination of grams and centimeters cubed. All right, so that's just going to be grams per centimeter cubed, just like speed, distance, and time is distance divided by time. All right, this is grams divided by centimeters cubed. Okay, so you just have to do the mass, which is 2 divided by 4, which is a half, isn't it? Yeah, so let's do the calculation. This is what I would always show. D equals M over V, so you don't get it the wrong way around. All right, D equals 2 grams divided by 4 centimeters cubed. Always put the units in so you can see what the units of your answer is going to be. Okay, and 2 divided by 4 is 1 over 2, 2 over 4. Same thing, all right? So we're just going to put 1 over 2 as our simplified answer there. Okay, don't need to get rid of it because I've got space. I've got space to do next question. So calculate the volume when the density is 460 grams per centimeter cubed. So we've got the density this time, and the mass is 200, and we've got the mass as well. So the volume is equal to the mass divided by the density. Okay, so the volume in this case is going to be equal to the 200 grams. Just get it the right way around. Divided by the 460 grams per centimeter cubed. All right, now that you don't have to worry about that, right? Because the grams are going to cancel each other out and leave you with the centimeters cubed as your answer. Volume is always measured in cubed units. These ones are centimeters, the units, right? But they're cubed because it's a volume, right? We'll get more to that in the next section. Anyway, so 200 divided by 460, we can knock a 0 off. That's 20 over 46. If we're simplifying our fraction there, which would be 10 over 23, and there's nothing more we can do with that, is there? So 10 23rds of a centimeter cubed is the volume for that particular question. All right, just simplifying fraction in the head. Should be able to do that at this stage if you're watching these sorts of videos. Right, and the last one, trying to squeeze this in, the mass when the density is 30 kilograms per meter cubed and the volume is 20 meters cubed. So in this instance, the mass is the thing we're calculating. M equals, and then we're multiplying density and volume together. So D multiplied by V is mass equals D, which is 30 kilograms per meter cubed, and then multiply it by the volume, which is 200 meters cubed. So 30 multiplied by 200, 3 times 2 is 6, and then put all those zeros on, 3 zeros. And that answer would therefore then be in kilograms, because that measurement for density is in kilograms per meter cubed. Okay, so kilograms is the mass in that instance. All right, I'll just get rid of that working because it looks a bit messy without. So you can see the answers clearly and you know how I've done them. All right, there you go. Now, number 2, we've got to calculate the pressure exerted by a force of 12 newtons by a cube with a side length of 3 centimeters. State the units of your answer. So it's a little bit more complicated, this one. But we're told that pressure is equal to force divided by area. So calculate the pressure. So we don't have to rearrange the formula or anything because it's in that form that we need it in. So P equals F divided by A, if you want to write it another way. Okay, the P equals 12 newtons, so that's going to be 12 and then N, big capital N for newtons, by a cube with side lengths of 3. Now a cube looks like this. There you go. There's a quick sketch of a cube. Right, and if that's 3 centimeters, then so's that and so's that. Okay, now what we're talking about is the area that we need here. All right, we need the area to do the calculation. So if that base there of that cube, that I'm just shading in there, if that base of the cube was exerting that pressure of 12 newtons, right, then it's the area that we need, right? And 3 times 3 is the calculation that we would do to get the area of that square. Okay, so that is 9 centimeters squared. All right, and that was the tricky bit in that question, I think. And now we've got that done. All right, the P is equal to 12 over 9 N per centimeter squared. So units is N slash centimeter squared, and 12 divided by 9 can be simplified down. So we could simplify that down to divide both numbers by 3, which will give us 4 over 3, 4/3, or 1 1/3. So I'm going to put 1 1/3. 1 1/3 of a Newton per centimeter squared. Okay, and that's the pressure. All right, maybe we could put P equals that as well down in the answer space. So let's have a look at the last question. Maybe slightly more complicated, more stuff happening here. Yes, this one, material A has a density of 12 grams per centimeter cubed. And material B has a density of 3.6 grams per centimeter cubed. I think I'm going to pause this and get the calculator in for this, because I'm seeing some decimal numbers, and we could probably do it without, but let's just make it easier and use a calculator. Probably be a calculator type question. So 2 seconds, and I'm back with a calculator ready to go. So we've got 12 grams per centimeter cubed for A, and that's the density. B's got a density of 3.6 grams per centimeter cubed. Material C is made up from 200 grams worth of A and 360 grams worth of B. I'm going to work out the density of C. So for us to be able to work out the density of C, the ultimate end goal of this question, what we need to do is we need to have the mass and the volume of the material C. All right, we need mass and volume. Well, we've got the mass because we can add the two masses together of the material A and B that make up C. All right, we've got the mass, so we can write that down straight away. So mass of C is equal to, and don't need to calculate for that, 560 grams. All right, but what we also need is the volume of C, and we don't have the volume of C. All right, so that's the thing that we're going to have to find out somehow. All right, now if we had material A's density and material B's density, and we've got material A's weight, mass, and material B's mass, then we can calculate the volume of material A and material B. So let's do that first of all. So volume of A is going to be mass, which is 200 grams, divided by 12 grams per centimeter cubed. All right, and then that, let's bring the calculator in to do that. So 200 divided by 12. Loves putting 11 when I want to put 12, doesn't it? If you've watched my other videos, you'll know what I'm talking about. 16.6 recurring. 16.6 recurring. That would then be in centimeters cubed. Let's not forget that's a volume. Okay, and then the volume of B is going to be calculated in much the same way, just using the different numbers. So with 360 grams, and we're dividing by 3.6 grams per centimeter cubed. So probably don't need the calculator for this, but here we go. Use it anyway. And we get 100. So 100 centimeters cubed. All right. Now, if that's the volume of A and B, all right, what can we do with the volume of A and B? We can add the volumes of A and B together, and we've got the volume of C, all right, because that is that follows. It's logical. It makes sense. So adding them together, we're going to do 16 point, and if you want to put the recurring decimal in, I'm not sure I could do it on this calculator. No, so I'm going to use 16. What can I use instead? 200 divided by 12 did 11 again, didn't it? There you go. 50 over 3 is what I'll use. I'll use the exact fraction to do the calculation, and then I'll add that to 100. There we go. So that is the volume of C. All right, so 350 over 3 centimeters cubed. Right, now we've got those two things, we can calculate the density of C. All right, so that is going to be mass divided by volume. 560 divided by 350 over 3. I'll just write it down. Divided by 350 over 3. All right, you can type that into the calculator. You just press your fraction button, 560 over, and then that was the last answer I had on the screen, so I'm just going to press answer. It's going to give me 24 over 5. Okay, and let's just work out what that is as a decimal, because it makes it make a bit more sense. 4.8. And that is in not in centimeters, that is in grams per centimeter cubed. That is the final answer. All right, so we had to do a little bit more in that question, didn't we? But we had to work out something and use that something that we worked out in our final calculation, because the end goal is to work out the density of C. All right, you do get some tricky questions like that. They do take a little bit of time to kind of figure out what it is you need to do. Take your time on it, you'll get the marks for it, it'll be worth it in the end. All right, hope you enjoyed that video. Thank you so much for watching. Thanks for all the support everyone's given me. Take care of yourselves and look after one another.